So I'm thinking maybe we clean up the code a little just to make it a little more presentable. What we'll do here is we know we're going to expand our code. We know that we're going to have 4 outputs and 4 inputs, and we definitely don't want to have this giant mess here.
Wow.
Of all this going on. So let's go through. Let me turn that off because we're going to be focusing on the code now. It's the good part. So we definitely want to clean this up because this is a beta program. This is you're first going in there, you're setting things up, you're testing to see what works, what doesn't. It's prototype. So now that we know this works, we're probably going to want to separate these things in the functions, right? Because we know we want to set a pin high, we want to set the others low, and we want to then go ahead and read 4 values. We don't want to have like ifs. We don't want to have all that. So what we're probably going to do, and I'm actually going to refer to the example that is on SparkFun's site. I mean, definitely one of the things about code is the fact that there's just tons of it out there. And if you're not familiar with the environment that you're in, definitely use other resources like Stack Exchange, everything. If you are a coder, these are things you use every day for, if you're doing C# or JavaScript or whatever. All this stuff exists for the Arduino code as well.
Hey all, this is editor Pirahtays. The point we're trying to make here is that there's tons of resources and reference code available out there that work if you're a first-time coder trying to figure things out, or if you're someone that kind of knows what they're doing but can't remember the syntax of a language. You'll see us struggle with that a little bit in the video. Anyway, back to it.
Right now we're still going to leave all the serial monitor stuff in there and all that, but we want to have some constants, right? And we want to have an array probably as well. So one of the things we're going to do is make sure you write comments for your code. We're going to go ahead and say that we've got pins 2 through 5 are the pins we will use to poll the matrix, the button matrix. Okay, and then what we're going to do is int poll pins, and that's going to be 4 values, and you should probably spell poll correct. And we're going to tell it that those are pins 2, 3, 4, and 5. Okay, so we've got those. So let's go ahead and check just to make sure. We're going to go back and look at our diagram and always check for if you're, when you're working with these microcontrollers, always go and check that you're looking at the Arduino pin numbers and verifying that, you've got your circuit connected to the pins you intend to connect them to. All right. So in our case, it is 2, 3, 4, and 5 are the polling pins. And then we're going to duplicate this because we've got pins. They're actually the analog pins. So on the board, they're labeled A0, 1, 2, and 3. But as far as Arduino is concerned for digital inputs, these are 18, 19, 20, and 21. So we're going to call these read pins. And there's 4 of them as well. And these are, like I said, 18, 19, 20, and 21. Pins, we'll update our comment. 18 to 21 are the pins we will use to read the button matrix. Okay. So now we've got all that. Now we got to settle this up. So we're going to leave this alone because we're still going to want our kind of just code in there to make sure that everything's running and doing what it's supposed to be doing. We're going to leave the serial commands in there for now, but we can go ahead and do this through a for loop. So to do that, we want to do for, and C# has ruined me for this, and so has ReSharper, because they have made this too easy on me. And I less than 4, because we've got 4 in our index. Now you could be fancy and probably even take that a step further and look at the length of the array itself. But in our case, we're only going to have the 4 pins,
we're only dealing with
cases.
The 4x4 matrix. So.
Yeah, we've got it. You can get away with it for a certain bit because of the fact that there's certain things that are going to be hard coded because you're tied to hardware, right? So It's not like all of a sudden you're just going to magically add another row of buttons. If you do, you're going to have to change your code anyway. So that's probably taking it a little too far. I mean, you could do it that way if you wanted to, but it really would be overkill. So we're going to go ahead and do that.
Yeah, there's only opening for 2 more digital input pins anyway.
Oh, okay.
Or at least on the A side, so 22 and 23.
Gotcha. All right. So we're kind of limited there anyway. So what we're going to do is we're going to do 2 things at once. So we're going to say pin mode, and then we're going to reference the pole pin I, and we're going to say this pin needs to be set to output, right? So we're doing this, but we're looping through. So we're going to set 2, then 3, then 4, then 5. But we can also do this and set these for the read pins at the same time, because we're just indexing the array, as input. Okay. So that kind of does all this for us. So we can get rid of all that. And then we also want to set digital write just to set an initial state for pole pin I to low. We want to set it low. And now we've done this. So now with that amount of code, we did everything we did before with, 6 lines or so, and it's a lot cleaner, it's a lot easier to read. If for some reason we end up using a different microcontroller that has these things connected to different pins, we don't have to rewrite our code now. We just have to go through and change. Exactly. You just change the constants up here in the array for the pins, and there you go. You can get into trouble a little bit, though, if you try to do too many things in arrays like this. You'll notice down here, now granted, with this thing, this is not going to be an issue. But you can see our sketch uses 4,500 bytes, which is only 15% of our program storage. You got 28K, it looks like. And then you've got some dynamic memory usage and everything else, leaving 2271 bytes for variables. So there is a limit with these microcontrollers about, how much you can do in memory and everything else. Some of the bigger ones, like the ESP, what are they? The ESP32, the ones that have the Wi-Fi in them. Some of those have some ridiculous storage in them. So you can run into issues with storage, I guess is my point. So there we go.
Yeah, be aware of what your limitations are.
Yeah, exactly. Know your limitations of your hardware. And if you do run into a problem, I mean, there is probably other hardware you could get that would do similar things. In our case, like I said before, we're using this specifically because this chip has a mode where it will appear as a keyboard to the system, or even a mouse. Actually, I think you can emulate a mouse as well, which is pretty exciting. Which, anyway, back to what we need to do here. Clean this up. So we've got that straightened out, but we still get this ugliness here. So we can optimize this in what's that?
You can take your digital writes out now, since we're doing that in the setup loop.
Well, we are, but that's just setting initial state, right?
Yeah, true.
So I think we should probably have a function here, right? I would think.
Yeah, you probably want a function so we don't have to keep redoing the if loops. We can just send in what button.
Just create a void function. Okay. Just like you do the loop. How do you pass in a variable, though?
The same way.
You just do the int whatever?
Yes.
Yeah.
I don't even know if it needs... Sorry. I don't even think it needs the typing on it.
No, I don't remember. Like, it's been so long. I thought C syntax required the type. Well, there's one way to find out. I guess if we do int, we don't want... What do we want? We don't want a pin. We do want a pin.
Oh, yeah, it does require the type. Sorry.
We'll do int index. Okay. We'll do that. Read matrix. Okay. And what do we want to do? We need to read each one. Right. We're just going to copy this from up here. So all we got to do is, if everything is low when we do the setup, we can assume everything is low to begin with. So if we go through and we loop through, we can set the pin to high. So let's do this way. So let's set the pin to high. And then down here, we're going to read the values. And then here, we're going to reset the pin low. And that's all we need to do. Yeah, there we go. So read matrix. So what do we need to do to read the values? We need to have another loop. I guess we should call this row int r.
Really?
And then it goes in there. And this is going to be column, right? And this one we want to read our, well, we're reading the values. So we want to digital read pin. Is that what we called them? We did, read pins. Okay, so we've got our value. Okay. So we want to say if that is true, I guess I could just write a function handle key press int row column. And then what did we have? Poll.
They're on.
Read pins C, right? This. We want to
handle the key press for row and column.
And then we want to break, I guess, right?
Yes, because we're only doing one key at a time.
Yeah, we're only going to do one key. So we're only going to handle the first one that it reads. I guess we don't have to, but we're going to for now. And then we reset the pin low and we start over. Button down. And then we're going to tell it row print row. Column, and then print ln. We'll print the line afterwards, and this just needs to be column. And eventually, you know, this will handle the code. But for now, that should work. And then what we need to do is we need to take all this out. Oh, no, that doesn't work. Can't do Control K, Control C. Does not work.
Is it just Control / like VS Code?
Yeah, you can do that, but that's a single line. Oh, wait.
I think if you highlight multiple, it'll just single line each of them.
Oh my goodness. Yes, you're right. So let's increase this to... Actually, let's leave that on. So we need to tell this...
You read the matrix.
Yeah, I guess we need to go through... Actually, we don't need an index, do we?
Nope.
Why was I thinking we did? I was doing things a different way in my head. Read matrix. And that's it. So now if we run this, in theory, this should work. Let's see here. Put our desk cam up here. Press a button. All right, so we got row 1, column 1. Row 1, column 1. Row 1, column 0. This button's falling out. That's the issue. That's row 0, column 1. Row 0, column 0. So there we go.
Nice.
So now, once we hook up the other pins, which if I actually switch these over, just double check here. Go ahead and zoom in here.
How did we get row 2, row 3?
Oh, because there's nothing tying those to ground.
Ah.
So again, if I touch them, you're going to get random things.
Oh, okay. That's right. The environment static.
Yep. So now 1 3 0 0 3 0 1. Yeah. So there we go. As expected. Wonky stuff. All right.
Progress. Yay.
Yeah. And additionally, if I press both of these, it should only, I can get my fat fingers in there in a way that you guys can see it here too. It's only going to read the first one. If I let off, then you'll read the second one. There we go. All right, so we'll leave it at that. We did our prototype now, so now we know the matrix will work. So let's move things here and wire up the perf board. So we're not going to solder this on yet, exactly. But we're going to solder, we've got the connectors, and we've got our pull-up resistors that we've got to go ahead and put on the main line. We definitely want to go ahead and line these up and put them on there around about where it's going to go. Get this here to make this a little easier so that this can sit down in there. Because basically what we need to do is we need to line these up. We don't have to, but it's going to make things easier if we line these up here. So we know we're going to put this here. Give us a little room there. We want to line this up with the A0 and A3 pins. And over here, when we go to put it on, we want to line it up with the digital 2 through 2, 3, 4, 5 pins. Because that's what we've done in our code. We can modify our code. If we accidentally made a mistake, we could modify our code in this case. We're not using any of the special features like transmit, receive, or certain pins do different things. If we needed to use the analog pins as analog inputs, we could go ahead and do that there that way. Then we also need to run these here on this side to make things easier. What we'll do is we'll run our ground. So what we'll do, we've got our ground here. So we're going to pull that ground out underneath, and we're going to run it over to this side of the resistors. We're going to have all 4 resistors here for our pull down resistors. So let's go ahead. Let's flip this over and probably make this easier and just bend one lead over and kind of go towards that way. Actually, we're going to have the ground's going to be towards the front, so it's probably best if I were to take one of these leads. What we're going to do, actually, we're going to kind of bend these out so we got some tension, and then we'll bend this lead this way and then bend these back a little, because all these on this side are going to just be connected to ground, so it makes it easier to go ahead and set up for things. Yeah, so let's grab our trusty soldering iron. Okay. Resistors are pretty tolerable with heat, so we can kind of dawdle a little bit. When you get to some other components, they're pretty sensitive to the heat. You really don't want to be dawdling with things. Put some light on this here so we're not moving around. Zoom in a little more, maybe. Give you a better view. How's that look? Now we're looking good. Okay. Well, it's not gonna be the best, but that's fine. It'll get the job done. It'd be nice if we had a custom perf board, but for one-off things like this, it doesn't really make much sense. So now that we got that, we'll just check this side. Everything looks okay there. Alright, so what we'll do is we will clip off our little excess leads here. Like I said, we're going to leave this one. We're going to end up connecting things to it. So then the next thing we have here is this connector. Right, I'm going to make sure also that we're still, we're in the right spot. We need to go in 19. Yeah. Uh-oh, fell out. 19. Okay. So for these, I'll go through here and bend this down a little. Screwdriver here. What we'll do is we'll run these over here. Push down on these a little and get them into place. Okay. Alright. So now we have that there. With having that connector there being plastic, we definitely don't want to be sitting on there too long with some heat. So we're going to go at this with more of an angle. And try to... There we go. And probably want to do this, secure this into place. And it's no big deal if you do accidentally get the pads cross-connected. You can go back and fix that. Solder's pretty generally forgiving. Kind of have to really screw it up bad. to not be able to get it to de-wick. Usually you can just run your soldering iron over it again real quick and it'll just pop off of the pad there, so you don't have to worry about it. There we go. Okay. So we got those connected there. Now over here, we'll check this. No, we don't want that there. We want it here. There we go. I see these are conflicting a little. I'm not going to solder this in yet. We want to be able to put it on our breadboard for testing. Still. Although, I guess we could solder up another one, or put headers on another one, is what I mean. But we don't need to do that yet, so let's go ahead and we will put our connector over here. And what do we got? One space. Be even. There, we got that there. So let's get that out of the way. Okay. Keep that there to keep it even. Keep it from falling over. And y'all can still see, so that's good. Kind of pointless if you guys can't see, right? That there. Okay. Now for over here, we're going to have to add some jumper wires. We're going to have to add some wires that come over to here to connect to the pins for the Arduino. But for now we're good. Let's clean that off and we'll put that there. And that's most of the soldering done. Next, we'll put this here and eventually we'll solder this into place. Shouldn't be too much more to do. We also have to run the ground from this pin over here over and down as well. So we'll get some small thin wire to go across and over, and we'll join that here. That'll make it a little easier. Go ahead and do that. So cool. We've gone ahead and we've created our code, and this code should just work for now. The next things we've got to cover are actually making this give keyboard commands, figuring out a way to set up OBS to get the keyboard commands, and then we just need to plug into the code what key presses to send back. We've got our code set up over here to be able to handle the key presses. Right now it's just doing the serial debug, but we'll have it actually send key presses and do that. So that ought to be fun. And we need to tweak things a bit because we will need to go into our model and model our base. Now that we know that we don't need to use a shift register, we might go into that one day, but we'll wire this up. All our model needs is to have space to mount this board and have a spot out the back, like a recessed area for you to be able to get the cable in here and plug this in. So we'll measure this up and model it and print our base, and then our case should be done, and it would just be a matter of wiring it up. So thanks, King, for joining us, and we'll go through the next one hopefully and see what happens.
Sounds good. Until next time.
All right, see y'all later.
Hey viewers, this is Pirahtays here. If you enjoyed this video, make sure you give it a big old thumbs up. And if you didn't, let us know in a comment below. Make sure you subscribe to get notifications for our future videos like this, and we'll hopefully see you in the next video.